Okay, let's finish 5.1 and talk about what happens if you're finding something else. Let's say they want you to find the interest rate given your future value, the present value, and the amount of time you accrued interest. So if we have something like $6,000 turned into $6,420 in future value after 1 year, find the rate. Then we can plug into our formula. 6420 equals 6,000 times 1 plus RT, so in this case R times 1. So 6420 equals 6,000 times 1 plus R. Divide by the 6,000. So that's equal to 1 plus R. This is 1.07 equals 1 plus R. Subtract 1. We get 0.07 equals R. Now remember, that's R in decimal form. What about in percent form? You go 2 decimal places to the right, so R is a 7% interest rate. Furthermore, you can find T if it's an unknown variable as well. Determine the present value P you must invest to have a future value A at simple interest rate R after time T. So here actually we're not going to determine T, we're going to determine P. So we know A, 9,500 equals P times 1 plus 0.06 times 10. So that's 9,500 equals P times 0.06 times 10 is 0.6, 1.6, divide by 1.6. So 9,500 divided by 1.6 is 5937.50. Lastly, we could have some word problems as well. Suppose you currently have $3,000, but you have a mysterious dream telling you need $4,500 in the future. Hey, you never know. For some reason, you believe these kinds of things. The best rate currently offered is a 4% interest rate. How long will you have to wait in order to have the money you need? Give the answer in years and days, assuming 365 days a year. Okay, so we know your future value you want is $4,500. You currently have $3,000. You have a rate of 0.04, but you don't know the time you're going to have to take. So the question is, I need to solve for T. Divide by 3,000. 4,500 divided by 3,000 is 1.5 equals 1 plus 0.04 times T. Subtract the 1. So 0.5 equals 0.04 times T. Divide by 0.04. And you should get 12.5 equals T. Now that means you need to wait 12 years and half of 365 days, let's say 183 days. So you need to wait 12 years and 183 days in order to have enough money, so I hope you don't need it sooner than that. Okay, and that's really all of 5.1, but we can go ahead and roll through to 5.2. So 5.2 is compound interest. It has a slightly more complicated formula because your interest starts to gain its own interest, so it gets added to your principal. So there's a lot more interest to keep track of. So we have the same pieces of information, except we have this n, which is the number of periods. That means if you make something like monthly payments, there's 12 periods where you're paying per year, and that affects the interest rate you're charged per period, and it affects the number of payments you end up making. So you have these two formulas, solve for A and P respectively. A, the future value of the amount borrowed is P times principal times 1 plus R divided by N to the NT power. Or solve for P, it's A divided by 1 plus R over N to the NT. It's really important that you understand order of operations here, the order this is supposed to happen, and put your parentheses in accordingly in the calculator. The thing people make the biggest mistake on average is not putting those in the right place. So make sure you put them in the right place. Now, let's just practice calculating it straight up, just like we did at the beginning of the last section. Find the amount of money and the interest earned in the account given the following. P equals 1,000, the rate is 6%, T is 2 years, and payments are made annually. So annually means once a year. We talked about this in the last video or 2 videos ago. T is 2 years, so T is 2, rate 0.06, and P is 1,000. So I'm finding A here. So A equals 1,000 times 1 plus 0.06 over 1 to the 2 times 1 power, or 1 times 2. It doesn't really matter, but if I clean this up, this is 1,000 times 1.06 squared, which you can do. So let's see what this looks like when you put it into the calculator. You've got 1,000 times 1.06 squared, which is 1123.60. Now, you'll notice compared to the beginning of the last one, this is very similar to the last problem. Same rate, or the beginning of the last section, same borrow, same rate, same time, and annually didn't affect that at all. But notice that we ended up with slightly more interest. And the reason for that is your interest gained its own interest. So it got that $60 that came from the first amount of interest got its own 6% interest, which is where the extra $360 came from. Let's try this one more time, and we'll use a daily of 365 days a year. You borrow $480, 4.5% interest for 10 years, but this time we're doing it daily. So that will let n equal 365. So we've got 480 times 1 plus 0.045 over 365 to the 365 times 10 power. So when you're typing this in, make sure to put in the right place your parentheses. You may need a caret for your exponent, and you may need to put that multiplication in parentheses as well to be safe. So we've got 480 times 1 plus 0.045 divided by 365 to the 365 times 10 power. Here we get $752.77. So if you recall back, there was one of these on the last set as well. I don't think we did it in the video, but by comparison, when you go daily, it does increase by more. Because you're constantly charging interest, you're nickeling and diming them. Now, what happens if you want to have a future amount of money you want to get to, and you want to know how much you need to deposit now? Let's do number 2. You want $7,000 after 6 months at a 12% interest rate, and they make quarterly payments. Okay, so this uses the other formula, P equals A divided by 1 plus R over N to the NT. So here, I need to do 7,000 if I'm putting in the calculator, divided by parentheses, 1 plus, this is my 0.12 over N quarterly, so over 4. All of this raised to the 4 times 1/2, because it's half a year power. So I really would need like an extra set of parentheses to be safe here. So let's see what this is. 7,000 divided by 1 plus 0.12 over 4 to the 4 times 1/2 power. And I get looks like I get $6,598.17. And we will continue 5.2 in the next video.